sir. I'm Harini. My roll number is 2340180441. My branch is ECEA section. Subject is control system. Subject code is 2334404. My topic is numerical problems and state space analysis. Firstly, we want to know what is the introduction of the state space analysis. First, basically, what is state? State is a group of variable which summarize the history of system in order to predict the future values. So because of the history which is used to can predict the future values. State variables, for example, it is an initial stage like t is equal to 0. It is an initial condition. When t greater than t naught, like t is greater than initial conditions, that time we can use to or convert the order predict values future values. So firstly, smallest state variables. The smallest state of variables that determine the state of the system are known as the state variables. It's determine the state variables is a group set of variables. State variables is like x, y, z. This type of variables, the set of variables is determine the state system. That is known as the state variables. Next one is state vector. State vector is it is a vector which contains the state variables as elements. The same as the state vector is as well as the state variable is same definition. It's only which contains state vector is contains the state variables. The advantages of the advantages of the state space analysis is it's analyze the is done by considering initial conditions. It's not only the all conditions, it's only done only initial conditions. It's more accurate than the transfer functions. You know very well a transfer function is output Laplace transfer by input Laplace transform. The transfer function definition that's more accurate in the way want the advantages is more accurate the transfer functions. This analyze the analyze of multi inputs and multi output systems are easy. You know transfer functions is like there's so many of in multiple inputs and multiple outputs is so complex. But in this state space analysis the multiple inputs and multiple outputs are if your system is analyzed, this is very easy form, but it's a very some it's very easy but process is lengthy. Gives information about controllability. First information about the controllability. So it's the works on the systems is control like that. It is applicable for all dynamic systems, not only the only one systems. It is applicable for all dynamic systems. This disadvantages is it's a complex technique use. Then I'm also told complex technique use means like multiple inputs and multiple outputs. It's a easy way, but it is a complex. So many computations are required. Many like many dynamic systems and many computations are formed. So my topic state space analysis. I am take this problem obtain the state model of the system described by the transfer functions. This question is y of s by u of s is equal to 10 by s square plus 6s x cube plus 6s square plus 10s plus 5. The given transfer function is y of s by u of s is equal to 10 by s cube plus 6s square plus 10s. Is the given. The firstly we apply the cross multiplication. The cross multiplication y of s into s cube plus 3s square 6s square plus 10s plus 5 is equal to 10 into u of s. Then you have multiply the y is multiple inside. Then s cube into y of s plus 6s square into y of s and 10s into y of s and plus 5 y of s is equal to 10 u of s. Converting Laplace transform into differential equations. Like this is a Laplace transform. This if you convert the differential equations is like that dq by dt square into y plus 6 d square y by dt square plus 10 dy by dt plus 5y is equal to 10u. And this is again we can write it as the y d cube by dt. Just you can write it as d cube. So uh, three times differentiation. So here we can write the three dots: y cube, y triple dash plus 6y double dash plus 10y dash plus 5y is equal to 10u. State variables, we find out the state variables. Y1 is equal to x1. If we differentiate this equation, dy1 by dt is equal to dx1 by dt. So y1 dash is equal to x1 dash, that is equal to x2. x1 dash, if you differentiate x1 dash, that is equal to x2. If y2 double dash is equal to x2 dash, x2, when you differentiate x2, then that is equal to x3 variable. x3 triple dash is equal to x3 dash. That's only here only three differentials. So if we stop the x3 dash, so substitute these are in substitute in equation 1, and you can write it as x3. Here y triple dash, here y triple dash is equal to x3 dash. So here 6 y double dash. So here y double dash is equal to x3. And next 6y dash, y dash is equal to x2, and 5y, y is equal to x1. So here we all are substituting in the equation 1, and x3 dash plus 6x3, 6x3 plus 10x2 plus 5x1 is equal to 10u. And this is the equation. Again we write it as the x3 is separate term, x3 dash, that is equal to, then another terms is you can write it as outside of the e is equal to. So 10u minus 6x3 minus 10x2 minus 5x1. Variables is x1, x2, x3. So x1 dash is equal to x2, this is equation 1. x2 dash is equal to x3, this is equation 2. x3 dash is equal to 5x1 minus 10x2 minus 6x3 plus 10u, that is equal to equation 3. And if we can, next step we can write it as the variables x1 dash, x2 dash, x3 dash, and again matrix form. So here x1 is 0, x2 is 1, x3 is 0. Here x1 is 0, x2 is 0, x3 is 1. In this equation, x1 is minus 5, x2 is minus 10, and x3 is minus 6. Next slide. And this form, and x1 dash, x2 dash, x3 dash, these are the variables, and x 0 1 0 0 0 1, and 5 minus 5 minus 10 minus 6, and variables is x1 x2 x3. And here also 0 0 10, then here, there is no u form in equation 1 equation 2. So only in u term is only in equation 3, so 10 into u. These are the pictorial representation diagram. Here this is the y of t, this is the u, input and output. Here this is the feedback loop, positive then positive. This is the, if 5x1, if you these equations we can apply in this block diagram. The minus 6 into x3, minus 6 into x3, minus 10 into x2, 10 into x2, minus 5 into x1, it is 10u. So we can write it as in this equation. Here y is equal to 1 0 0. How can we write it as in this equation is x1 is equal to y1. In this term only x1 is equal to y1 only term is there, there is no x2 x3 x3 term. So y is equal to 1 0 0, and in the variables is x1 x2 x3 plus 0 u. Thank you, sir.